Okay, so we're going to look at lenses, dispersion, and electromagnetic spectrum. Okay, the convex lens, okay, so it looks like this, is a type of converging lens. So we did this experiment in class, 3 rays going in, go through the lens, they will converge through a point, okay. Just like this diagram here. So some important words here. So we've got a lens axis as the line going straight down here. We have got our principal axis, which is essentially is the line going across that way. So when we draw diagrams, we only have to put in these 2 lines, and you can just do a little symbol to show that what type of lens it is. We've got the principal focus, it seems to be where all the rays go through, and that can be on both sides, because in this case you can shine the laser this way, and there'll be a principal focus on both sides. Focal length is a distance from that focal point back to the lens axis. Okay, when we're looking at lenses, we have a few describing words. So this there is an object, and we have 3 images. Now this one here is virtual, and these 2 are real. Now if you think about it, this stuff on this side, the light here, is not really there. The light's actually travelling from the object through the lens. So the actual light is found on this side. Now, what we also have is magnification. So this one here is magnified, okay. This one is diminished, or is actually the same size. Let's just say it was smaller, we'll say it's diminished. And the other thing is that this one is also inverted. Then when we find images, we're going to draw a diagram to scale. So we're going to draw it using a ruler. We'll draw the 2 axes, draw what the actual lens is. We will draw in the 2 focal points. We'll draw the object, and then we're going to use that setup to find the image. And we're going to do it all to scale. So the first one's going to be parallel to the principal axis. So the first ray is going to be parallel to the principal axis. Okay, we're going to draw another one that is through the focal point nearest the object, or you could also do another one through the intersection of the lens axis and the principal axis, so through there. Okay, so there's 3 different sort of rays you can do. So let's do an example. So the first step is we're going to draw a ray that is parallel to the principal axis. Should do this with a ruler, going this way, and then this is a converging lens, so it's going to go through then the focal point. There's also another one that will go through the focal point on this side, and then that will go parallel to the principal axis as it goes through. And we could do one more. We can go directly through the intersection of the 2 axes, and it'll go down there. And then your image is found where the rays overlap. And then you should describe it. This is real, inverted, and it's probably the same size. Okay, so this one here, let's do a ray going straight across. Okay, then goes through the focal point. We could do one that goes through the intersection, and we could do one that appears to go through from that one, and then they'll go straight. So we've got 3 there. Where do they overlap? Well, they don't overlap on this side. Okay, so there's no overlap on this side. So what we're going to do is we're going to project the rays back, just like our brain would do. Imagine something project it, and we'll find an overlap there, and that's where our image would be. So this one will be virtual, magnified, it's very large, and upright. And let's do this one here. So this is right on the focal point. Arrow across, go through that point there. Let's go through that point there. And we can't do the other one. Now if you actually look at this, there's actually no intersection. And there's no intersection here. If we project it back, they're going to be parallel. So there is no image. Just be all blurry. And your turn. You can now do these. Okay, 2 of them. Now which example could be used as a magnifying glass? So we want one that's magnified, okay, and upright. One that did that was where the object was inside the focal point.